Hello, I'd like to talk with you today about predicting auto claim losses by utilizing machine learning to predict future losses for policyholders. I want to share this subject with you today because it's something that I'm passionate about, leveraging artificial intelligence and machine learning to help in the auto industry for insurance companies, but not also for customers. I've worked at State Farm Insurance over the past 16 years in varying roles in auto claims, including currently leadership. Our mission is to help customers recover from the unexpected, but also to be competitive in the industry. And that's not only by income, but that's by being competitive through price and also competitive through the market as well. So these are the things that I'm going to be talking about with you today. First off, why is this study important? Role of machine learning in auto insurance, analysis, findings, and why is this important to you, and why do we need your help today? At the end of the presentation, you'll have a better understanding of why we need your help with this matter as of importance. First off, the data set that was utilized in this study came from Kaggle.com, and it is called Car Insurance Claim Prediction. This was a very large data set with over 59,592 examples of data with 44 total attributes. The data type that was used in this data set is nominal, integer, and real. It utilized secondary data, which is data that is collected by others, but also structured data, which is data that is organized into tables. It utilized ordinal data, which can be categorized and ranked, but can't be described between the rankings, such as education level. Ratio data was also used, can be categorized and ranked with equal intervals between the neighboring data, has a true zero, such as someone's age. Some of the tools that we'll be using and models we'll talk further about. The tool that we will be using to run the models is a program called RapidMiner. It's also called Altair AI Studio. It leverages machine learning and uses models to quickly and efficiently evaluate the data. And you can completely customize it based on the user's needs. It's what we utilize for this study today. We also used AI, which is an auto model feature that is in RapidMiner, to evaluate the attributes and also the data that we use throughout the study. We are going to be looking at two different types of models. Specifically, will be logistic regression and decision trees. So here, why is this important to predict future auto claim losses? Well, for auto insurance, the ability to predict losses customers would have in the future would mean that you hold a competitive advantage over your competitors. You can beat them on price. You can attract customers sooner, but you can also predict for what years are you going to have heavier losses and therefore may need to increase rates. So some years could be higher storm catastrophes, some years may be less. The ability to predict those types of and forecast those types of losses can yield extremely large advantages for insurance companies. You can outprice the competition. You can also, but primarily, save customers significant amounts of money, but also attracting and retaining those customers as well. You can staff accordingly based on accurate loss forecasts. So if you know you're going to need more staffing, you can ramp up throughout the year and plan for those effectively. So we'll talk a little bit about auto insurance, and we'll be blending into our models that would be, but as an overview, for auto insurance, just in the year of 2023, there were 288.5 million vehicles just in the United States. So, opportunities for insurance carriers to compete and capitalize on their share of the customer base. So if you take that 288.5 million vehicles in the United States, that's the overall size of the pie, if you will, of the auto industry. So who controls the higher piece of the pie? Also controls the customer base, and therefore would be the number one carrier, which is always the goal. We always want to be the best at what we do. And so that's what we look at in the auto industry, is how much of that competitive advantage do we carry, and how much of that can we capture in the future, in 6 months from now, in 1 year from now. This study just so happens to be looking at, we'll be predicting our Y variable, or independent variable, will be predicting policyholder losses within the next 6 months. And it just so happens that auto policy terms run every 6 months. So when you purchase auto insurance, it is for a 6-month term, and then that term renews every 6 months. So there are X variables, or our dependent variables. We'll talk through those through AI modeling. We were able to identify the following test variables or attributes that will be the core X variables we'll use throughout this study. And so those are policy tenure, age of the car, age of the policyholder, adjustable steering, cylinder, engine size. So is it a 4-cylinder, 6-cylinder, or 8-cylinder engine? Does it have front fog lights, population density, brake assist, or anti-lock brakes? And is the driver's seat adjustable? So surprisingly, some of these X variables that we have identified here were actually some of the strongest that were captured throughout the model. Some of them were not foreseen at all. I would not have considered that adjustable steering, front fog lights, and adjustable driver's seat would be important factors to predicting a future auto loss, but the model found those, and we'll talk more about those as we go forward. Some of the X variables that I did expect to use from the from the raw data set, just in my cursory review, would be age of the car, age of the policyholder, cylinder, population density, and anti-lock brakes. These are all factors that we use today in rating. So these would be completely expected to see. One of the great features about RapidMiner is its ability to use AI to help identify which attributes or the X variables may be the strongest. This tool can analyze extremely quickly many variables. In this case, it was a total of 43 that were evaluated. And it found 9 variables that were the strongest. And so those are the 9 that we talked about and will be continuing to use. And the results will be based on those 9 variables. So when you see that the total attributes were 43, I knew I needed to get those down to a more manageable level. And so with these 9, really helped to accomplish that goal. All right, so the first model that we ran was through the decision tree. And it was found that on the overall model, you can see here in the top left corner that when the auto model or AI machine learning was ran, you can see that all the models predicted exactly the same results of 94% on those 9 variables. I also reran the experiment to see if all 43 would make any difference, and it did not. Auto model found the decision tree was the fastest and most efficient of all of them. When we looked at the receiver operator chart or the ROC, it did show pretty significantly poor performance for all models through the tool. And so we'll get into a little bit of that here shortly. First off, we'll be looking at the decision tree and the performance of it. The accuracy came through at 93.6, and the classification error came back at 6.4, which looked extremely promising right off the bat. But when we looked at the data in the confusion matrix, and that's what's listed down there below in the 4-quadrant chart that are colored in tan and darker tan. Top left corner shows 15,671 that were predicted to have no losses. So that appears to be pretty strong. It predicted all of the claims that were not going to occur, or that the policyholders would not have a loss. But if you look on the bottom, on the bottom right, that 0 there means that it predicted 0 losses for the future. So in looking at whether or not the decision tree is a strong model for our Y variable, it did not perform well because it was not able to predict any losses in the next 6 months. So it is not a strong model, and therefore we would not be proceeding with using this model moving forward. So we move to logistic regression. So this is our manual look at logistic regression through RapidMiner, through the model itself. Two variables came to be pretty strong when we evaluate the p-value of those. So any variable that is 0.05 or less is considered to be significant. And so we found that policy tenure and population density were 2 of those strongest ones. And we would expect those to be, because those variables are used in rating and in forecasting today. Logistic regression did predict 39.5% of the sample would have a loss in the next 6 months. As you can see, 444 were predicted correctly. However, it did miss 680. But it is a promising result because it was able to predict some of the losses, which performed much better than decision tree. So we look at the ROC, again here for just the logistic regression. Performs some better. It is still not strong. It does not appear to be strong at all. The lift chart for logistic regression is encouraging, as it does show some of the forecasting we talked about. Out of the first 3 bins, you have 447 total that were able to be predicted. The first 3 bins represent about 8.6% of the total results of the testing data. 30% overall of the lift chart itself, so each bin is 10%. That is encouraging, which tells me that it is possible for us to better utilize this technology. So where do we go from here? So the results for logistic regression are encouraging, but additional data collection and studies need to be completed to get a better understanding. Other factors to consider would be claim history for the policyholders, citations, and even tickets from the police, or driver's record. How safe is that driver? Looking to the future, again, more data is needed. This data set with 59,000 only represented 0.02% of the entire vehicle market. We need much more data. Predicting losses is the #1 problem for insurance companies. Insurance companies, we employ teams of actuaries to help with data analytics, rate making for premium and forecasting. One thing that we look at is how will advancing technology such as vehicle autopilot affect insurance and losses in the future? And so these results I've shared with you are small but promising, and it shows it is possible to achieve predicting auto losses. So with your help, with the additional funding that we're requesting from today, we are hoping to close this gap and have a much better result. I want to thank you for your time today. Thank you for consideration, and I look forward to speaking with you in the future. Thank you so much.